Okay, so let's do this problem. So it says create number lines for the following polynomial functions similar to the ones in problem 8-27. So based on number of factors and all of that, you can find like the zeros and also the degree. So because there are 4 distinct factors, there are 4 zeros, and they come from here. So they're the opposites, or what makes this parentheses 0 each time. So -3 from this one, -1 from this one, 1, and 5. Now, because there are 2 factors here, because of the power of 2, and then that's 3, 4, 5. So the degree is 5. So that means it starts down at the bottom and will end going like this. Okay, and then depending on, like, if the number of factors is odd or even, tells you if it crosses or bounces. So at -3, since the power is 2, it bounces. So it starts here, and then it bounces, and then crosses, crosses, crosses. So because these all happen an odd amount of times, and this one happens at even, so it bounces, and these happen an odd amount of times, so it crosses. And then basically you just highlight where it's above the x-axis. So it's above the x-axis here, and then here. Okay, this next one only has one factor, in -4, and its degree is 3. And then because the leading coefficient is negative, instead of starting here, it starts up here. So it kind of comes down here and like this. So it looks like that. And then where it's positive above the axis is just here. Okay, and then for this one, it's 4 factors, none of them are repeated, so this is degree 4. And then the zeros are -1 from here, 0 from there. I did it out of order because I need to do it in order on the number line. And then, -4 from here, and then 3 from there. That doesn't need to be like very perfect. Okay, and then because it's degree 4 and the leading coefficient 0.2 is positive, right, then both the ends are going to be like this. So it's going to go, and they all happen once, so it crosses every time. So it's going to cross, 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 cross. And then you just highlight areas where it's positive. So from above the x-axis, so here, here, and here. Okay, so basically we're going to just do this here. We're just going to do the sketches. So it's going to be degree 3. And then the zeros are -1, 0, and 3. And then because the leading coefficient is negative, instead of it's starting down here, it's starting here, and it crosses all of them. So cross, cross, cross. Okay, and it doesn't really matter like how high or low your peaks are. It's just a sketch, right? Like if you were to graph in your calculator, you'd actually be able to see if like you're having a shallow or a really high peak, but this is fine. Okay, and then here your zeros are -2 from here, 1 from here, and 4 from here. And then because this happens twice, and then this is all, and then 2, so then this is degree 4. And then, so you know, and the leading coefficient would be like whatever number is in here. So since that's basically +1, it's positive, so you know they're both going to end up like this. And then it bounces at 1. So you go, it crosses here, then bounces at 1, and then crosses at 4. So it's like that. And then here, this is degree 4 because there's 3 of these. 1, you add them together, degree 4. There's 2 x-intercepts, -2 and 4. And then because this is an odd number, it crosses, right? It only crosses for even ones. So like this is technically, this is 1, so these are both odd exponents, so they cross. So then it looks like this, more or less. There might be some stuff going on there, but that's fine. Okay, so it says, without graphing, determine where the graph x² + 6x + 14 intersects the x-axis. So justify your answer. So it crosses the x-axis when y is equal to 0. So you set it equal to 0. And then if you can factor, it doesn't look like it factors, so you can use completing the square or the quadratic formula. So -6 plus or minus 36 minus 4ac all over 2a. And then what happens is you get a negative number underneath the square root. So there are no x-intercepts. Okay, so for 33, for each set of points given below, write a possible equation in standard form. There's a typo here. The 4 isn't supposed to be there. It's just those numbers. So remember, it looks like this, right, where C and D are your zeros. So it's y equals, and then it's just a possible equation. So since you don't have a third point, your A could just be 1, and then it's x plus 3 and x minus 1/2. You could also choose your A to be something other than 1, so this would possibly be an answer. Or you could also just make the answer to this be 1/2, so it could also be like 2x minus 1. So these are all possible ones. But when you have 3 points, right, it is and then instead, right, for in standard form. So then to do that, you multiply that out. So then you get 2x squared plus 5x minus 3. This is possible answers. Okay, and then this one for sure, because you have this third point, you do have to solve for a, and there is one answer. So it's y equals a times x plus 3 and x minus 2. Then you plug in this value to solve for a. So -12 is y, and 3 is x. So then that's 6 and 1. So negative 12 equals 6a. So a equals negative 2. So then this is it in factored form. So in standard form, you get negative 2x squared minus 2x plus 12. Oops. Like that. Okay. Let's go on the next page. Okay, it says what the degree of each polynomial functions for below. So the degree, right, is the highest exponent. So the degree of this one is degree 2. This one is degree 5, right? That's higher than 2. And then these ones, you can only kind of like guess like at least their minimum degree, right, based on the turning points. So if you have like, so it has 2 turning points, so then your degree has to be at least 1 higher than the amount of turning points that you have. So degree 3. This has 1, 2, 3 turning points. So your minimum degree must be at least 1 more than the amount of turning points you have. Okay, so consider the following types of graphs, which the graphs are polynomial functions. Okay, so y equals x is a line, and that's degree 1. So this is a polynomial function, the line, sorry. The parent parabola, y equals x squared, right? That's polynomial of degree 2. So the parabolas are polynomials. And then the parent cubic is like this. And that's a polynomial of degree 3. So the cubics are that. The exponentials and the circles are not polynomial functions, right? Polynomial functions are only like the powers of x and or some sums of powers of x. Okay, so solve the system's equation below. The best way is to solve by substitution. So plug this in for y here. So then you get x squared plus x squared minus 4 squared equals 16. Oh, actually, that isn't the easiest way. Because what happens is you get to the 4th. So solve this one for x. So then you get y squared equals 16 minus x squared, and then square root it. And then plug that in, so then you have oops. What a mess of a video. That's also a bad idea. Solve it for x. So, there we go. So, x squared equals 16 minus y squared. Then, x equals plus or minus square root of 16 minus y squared. And then you get y equals, this is how to do it, 16 minus y squared minus 4. So then you get y equals 16 minus y. So the squaring undoes the square root. So now we're not getting, so the reason why I erased the other two ways are, those ways are possible ways to solve them, but you get to the 4th power, and we don't know how to solve those. We only know how to solve quadratics. So the highest power we're getting is 2 now, not 4. Okay, so then set it equal to 0, so you get y squared plus y minus 12 equals 0, and then that's y plus 4 and y minus 3 equals 0. And then so you get the y coordinates are negative 4 and 3. And so then, right, this is a circle and a parabola, remember, so you could have possibly like 4 points of intersection. So plug in these for y, so then you get negative 4 equals x squared minus 4. So then you get x squared equals 0, so x equals 0. So you have the point 0, negative 4. And then plug in 3, you got 3 equals x squared minus 4, add 4. And then you get plus or minus root 7. So root 7, 3, and negative root 7, 3. So here are the points of intersection. Okay, so that's it. Thanks for watching. See you next time.